So far we have considered gravitational force between two point masses and gravitational force between a solid sphere and a point mass. Now we get a doubt. What will happen if the solid sphere has got a cavity? Then how to calculate the force? For this one, what we have to do? First of all, we have to suppose that the solid sphere as a whole is present without cavity. Find the force exerted by it on the point mass. After that, we have to consider that in the place of a cavity, if an equivalent mass is present, and we have to find the force on the point mass. Because the cavity is present, so much force should be detected from the earlier force. Now let us see it in detail. Suppose we have got a solid sphere of radius r and mass m. Suppose a point mass is kept at a distance small r from its center. Then mass of the sphere without cavity is capital M. The force exerted by the solid sphere on this point mass F1 is equal to gmm by r square. Suppose we make a cavity. This cavity has got a radius r by 2. You can be given any cavity of any radius. Then how to find the mass of the equivalent mass of that cavity? We know that for a sphere, mass is proportional to cube of the radius. Here we are taking radius r by 2, so the mass will be equal to how much? M by 8. Now what we do? We imagine that this sphere is absent, only this matter is present. That is, mass is m by 8 and point mass m. What is the distance between the center of this one and this one? This distance is r. This is r by 2. So the remaining distance is r minus r by 2. Now the force exerted delta F, that's equal to gm by 8 divided by r minus r by 2 whole square. Now net force, because so much force is reduced, so the net force is this minus delta F. F2 is equal to F1 minus delta F, that is gmm by r square minus gmm by 8. R square I have taken out, bracket 1 minus r by 2 r whole square. So F2 is equal to gmm by r square bracket 1 minus 1 by 8 into 1 minus r by 2 r whole square, or this can also be written as gmm by r square bracket 1 minus 1 by 8 bracket 2r minus r by 2r whole square. Then what is the ratio of the forces? Ratio of the forces with cavity and without cavity on the point mass is given by F2 by F1, this by this, gm by r square will get cancelled. So finally what remains? 1 minus 1 by 8 bracket 2r minus r by 2r whole square. Now in the earlier examinations, one question was asked where this distance was given as r. That means from the center, r is equal to how much small r? This will be 2r. So here we have to write 2 capital R. 2 capital R means 4r. 4r minus r is 3r. 3r by 4r square. R will get cancelled. 3 by 4 square is 9 by 16. 8 ones are 8 twos are. So you will be getting 9 by 2. That 2 will go to the numerator. 1 minus 2 by 9. That's equal to 7 by 9. I hope the answer is clear. After this, we'll consider this point mass on this side and see what will be the force and what will be the ratio of the forces. Now let us take this point mass. On this side at a distance r from the center. Then as before, mass of the sphere without cavity is m and force exerted by the solid sphere F1 is equal to gmm by r square. Mass of the cavity of radius r by 2 is m by 8. Negative force exerted by the cavity delta F is equal to, now the center of the cavity is at a distance r plus r by 2. So here we have to write r plus r by 2 whole square. The net force exerted by the cavity is the force exerted by the solid sphere minus the force exerted by the cavity. So this can be written as plus, on simplifying we get it plus plus. So the ratio of the forces is F2 by F1 is equal to 1 minus 1 by 8 2r plus r by 2r whole square. As before, if small r is equal to 2r, then this will be 4r plus r 5r, 5r by 4r, r will get cancelled, 5 by 4 on squaring 25 by 16, 8 ones are 8 twos are, this 2 will go to the numerator, 1 minus 2 by 25, so that will give you 23 by 25. Like this you can solve any kind of problem very easily. Okay, I hope it is clear to you.